Hello, thank you everybody for coming here. This session is what's new in Xamarin.Mac and Xamarin iOS. I just want to warn you, this is a talk intended for users of the existing APIs to know what is new. If you're new to the product, a lot of this is probably going to be a little bit advanced. If you're new, a lot of this thing is like, oh, I didn't know it was there. If you're looking for what is new in iOS 8, on the other hand, there's a separate session later today or tomorrow about just about the iOS 8 platform. So this is just what is new in the runtimes and what are we doing to unify these two things. So let me get started with we historically have had two runtimes. They were very similar in spirit. They shared a lot of code, our Mac runtime and our iOS runtime. And this is natural because they both at the core, even in Apple's world, they share a lot. So core foundation, and all of these things. There are some significant differences, though. On iOS, we've always used a very static compilation system because iOS does not allow just-in-time compilation. And on the Mac, we basically leveraged the fact that we could compile code dynamically. So that's what we did. We compile code dynamically on the Mac, and we compile statically on iOS. So we are actually converging these two runtimes, and it's taking us a very long time to get there, and I'll get into some of the details during the talk. But we're basically converging the two runtimes, and they're going to share all of the same infrastructure, except for the APIs that don't exist on the other platform. As you know, we've completed our iOS 8 support, and we ship on the same date. Mac is a little bit, takes a little bit longer. One of the reasons is that the Mac just has a much larger API surface, partly because they just have had a bigger history than iOS, and that's the only reason. The one thing that is important about the Mac is that Apple has stopped shipping 32-bit APIs. For the last couple of releases of the operating system, there's a number of frameworks that are no longer available as 32-bit frameworks. So for those of you that have been using Xamarin.Mac on 32-bit modes, in 32-bit mode, this was a problem because these APIs were not available. Apple just does not ship them, and there's no way of getting to them. So we're actually shipping our 64-bit support now. And we'll talk about what we're doing with our 64-bit support. And to do that, we'll talk about how we came to solve the 64-bit problem with a thing we call the unified API. So in the past, we used to have the monotouch namespace. We had monotouch.something, like monotouch.uikit or monotouch.coregraphics. .cgrect, for example. And now we also had monomag.coregraphic.cgrect. With the unified API, we've done a couple of things. We've decided to both address the 64-bit problem and fix this compatibility issue. So the situation is that, like I said, Apple is moving to 64 bits, and we wanted also to support sharing code more easily between the two platforms. So we wanted to solve this problem. So we made a decision when we started the bindings for iOS and Mac that mapped the data types available on iOS and Mac at the time to the native .NET data types. So in particular, Apple surfaced this type def called NSInteger. And NSInteger was a 32-bit value at the time that we started. There was no 64-bit version at the time. So what we did is we mapped NSInteger to system.int32. That meant that there was a no marshalling approach. If the operating system gave us an NSInteger, we knew it was int32, so it could just pass through without any conversions. And we applied the same idea to a lot of other data types. CGFloat was a 32-bit floating point, so we mapped that to system.single. This is what we call float in C#. But over time, both Mac and iOS evolved, and they added support for 32-bit platforms. So NSInteger became a 32-bit data type on 32-bit system and a 64-bit data type on 64-bit system. So essentially, NSInteger depends on the natural size of your architecture. And this idiom does not exist in .NET. The .NET framework does not have a native data type. Well, there's one, but with one caveat. There's no native data type that adjusts automatically to the platform. Those of you are probably thinking, well, there's system.in.ptr. And that automatically adjusts to the platform. And you're right, but there's a couple of problems with system.in.ptr. First, it doesn't support the regular arithmetic operations. So it doesn't support plus and minus and multiplication and division, a couple of things. It actually supports plus, but it doesn't support the typical arithmetic operations on it. And it also has a very strong connotation in the .NET world. int.ptr has a connotation of this is a handle. This is a handle, and you should treat it as an opaque data type. So we couldn't really use that thing at the time, and we had to solve that problem. So what we've done is we've chosen to introduce new native data types. These data types do not exist in .NET, although they can be compiled with a regular .NET compiler, so this is very interesting. And these new data types are 32 bits on 32-bit system and 64 bits on 64-bit systems. It's the equivalent of the C typedef, but the notion of a typedef does not exist on C#. So this is the list of types that we're introducing with the Unified API. And the Unified API is available today. You can start using it today, but we'll get to a couple of the caveats as to why we haven't officially finalized it. So the important pieces are here. The NS integer data type in Objective-C, which used to be, so the second column is what did we map it 5 years ago. These are the data types that you're familiar with. So they were very natural C data types, C# data types, ints and uints and floats, or rectangle lefts and pointfs and sizefs. And the third column represents the new Unified API data type. So we introduced a number of new data types: system.nint, system.nuint, and system.nfloat. They look a little bit strange because they don't follow the .NET convention of being uppercase, but we tried to make it look nicer for writing C#. So instead of typing int, you type nint. Instead of typing float, you type nfloat, provided you have the system namespace in scope. Our virtual machine, when running on iOS or Mac, knows about these data types, and it cheats. It cheats, and it turns it into the underlying ints or longs of the platform. So there's no performance change. If you were to run this in .NET, which you can't, because .NET doesn't have any integers, it would still run, but it would run slower. So what we've done is we taught our virtual machine and our compilers that these data types needs to be treated as a native data type. So that's what we did. And we came up with this solution because it allowed us to use the existing Visual Studio compiler and the existing Microsoft C# compiler to compile the code on these platforms. So the source code can be compiled with either our compiler or their compiler, and it will generate binaries that will still be consumed by the Mono runtime engine. Also, for the composite data types, these actually pose a bigger problem. The system drawing types that at the time we thought this was genius, will be able to interrupt with all this system drawing code. The problem is that these data types are defined in terms of floats, right? So rectangle left is defined in terms of a 32-bit float, and the same thing happens with points and sizes. Everything was defined in terms of 32-bit floats. And Apple has chosen a bold direction. I can't argue with their direction. I'm not sophisticated enough to know about cycles and how many cycles are spent here or there. But they've made their rectangles, points, and sizes be 32-bit on 32-bit platforms and 64-bit in 64-bit platforms. So this poses a problem. And the problem that it poses is that it breaks source code compatibility. So wherever you had an int, now you need to make it an int, right? So since we're going to break source code compatibility, we decided to fix a few problems in this process. So let me take a step back first. The classic API, the one that you're using today with Mac and iOS, will continue to support that as is, and will continue to evolve it. So if you like your API and you don't want to make any changes, we'll keep supporting you. And in fact, we use the same core to maintain both trees at the same time. So to us, there's no added cost to support both API for as long as we need to. So if you're happy with the current API, you can keep using it. But if you want to share more code with the Mac, or you want to use the 64-bit only APIs, then you need to move to the unified system. So in the unified API, we decided to fix a few problems, and I'll get to that. But some of the benefits, the immediate benefits, is that you can share more code between the Mac and iOS. So stuff that before was a little bit inconvenient, or you had to have a bunch of if-defs or ugly hacks in your source files and every source files, all that stuff is gone. So that is really good. Since we're breaking source code compatibility, because you have to change this, we've also been fixing a few mistakes in our API. We're removing deprecated methods. So stuff that Apple says don't use anymore, we're taking it out. So as you do this migration, you will have a chance. Well, you will have no chance, but you will change. You'll remove your deprecated APIs. And most importantly, we've added a fantastic new feature in the last year, which is protocol support. So we mapped Objective-C protocols to C# in a way that we're finally proud of and we like very much. Problem is, we can't fully support it unless we break source code compatibility. Well, binary compatibility. We preserve source code compatibility, but we break binary compatibility. So that means that you do need to rebuild. So we figured with Unified API, we're going to take the liberty of going and fixing these issues. And I'll walk you through some of these things. I'm going to get to some of this water. By the way, if you're expecting some salmon slapping in this session, there are no salmons hurt in this session. Sorry about that. But we will be posting the source code to the salmon slapping, so you can slap at home or whenever you want. So the things that will break your code are the protocol changes, and we'll talk about this in a second. The reason why this is a preview and why we're not really shipping it right now as an officially supported API is the following. We are in the process of fixing things so that protocols work the way that you want it to, or the way that most Objective-C samples work. I'll get back in a second. But most importantly, our tooling is not ready. We were hoping we would release Unified API at its own cadence, and we would ship it when it was all ready. As you can imagine, we had to audit every single API out of those, God knows, 40,000 APIs. We're reviewing every single one of them. A human reviewed every one of them. We used tools and humans to make this happen. And we're going to ship it when it was ready, but our hand was forced, and I'll get back to that in a second. So there are three things that are currently pending. The first one is the designer support for custom controls. So you guys know that since last year, we're able to create custom UI views or UI view controllers, and you can instantiate those in the designer and see them live. This support is not available for Unified yet. We're working on that. The second one is that Node.js and components are being updated. So we are working to get the whole story there. It's not ready yet. We got the team at Microsoft that maintains NuGet was very kind, and they did ship an update just 2 weeks ago that adds the support, but when we launched this, it wasn't quite there yet. And finally, our Xamarin Forms is currently working on the old API, so we need to update that. So this has a couple of implications because third-party components, the compatibility, binary compatibility breaks. So we still need to do some tooling for you guys to not go through the pain of dealing with this. So what does it mean that, how do you switch to Unified today? Well, today you have two options. If you're starting a new project, we have new project templates that get you started on the Unified world, and you're off to the races. If you have an existing piece of software, so if you already have some C# code that you're working with the classic API, we have the Migrate to Unified API tool that will do the underlying project file migration, but won't update your source code. We do have a Perl script, well, a series of Perl, well, a shell script that runs Perl multiple times that will fix all of your monotouch code And in my opinion, we'll get about 95% of the work done. It's not ugly. I mean, it's not beautiful, but it gets the job done, and it will show you my amazing Perl skills. That said, we understand that some of you are not fan of dropping to the command line and running some command line script. So next month, we're going to have the migration wizard. In fact, the migration wizard has already been completed. It's just not in the current preview. So remember, the one pending thing is, why would I want to move to Unify? There's this protocol thing hanging over our heads. We'll get back to that in a second. So let's talk a little bit about the mono runtime and what we've done in the mono runtime. So a couple of things. Since last year, we've moved Mono to our latest 3.0 series. And we've actually changed the way that we adopt Mono. In the past, we used to wait for 2 or 3 years before we upgraded Mono. We've decided to eliminate that completely, and now we're more in a, what is this thing called? There's a fancy new word for this. I can't remember, this Japanese thing. It's like a jaw, one of those. You're getting there? Lean. I think it was lean. Who said lean? I'll get you a sticker. So basically, we're reducing the inventory. We're moved into a world where we're reducing the inventory between patches that we have in the Mono runtime and how long it takes to ship to customers. So now we're tracking Mono 3.0, the latest version. It brings all of the latest .NET 4.5 APIs, so you're no longer limited to all the old APIs that we had. And we introduced a number of features: async programming, pickles, and Node.js, and F#. There's a number of sessions that you should check out. Joe Mayo, sadly, you already missed that session. It was today, but you can watch the video later. Daniel Plaisted from Microsoft is doing a session on portable class libraries, shared asset projects, and Node.js. And Rachel Rees has the F# talk. There's actually 3 F# talks. We're big fans of F# at Xamarin. In particular, you will not believe this. Our design team, the people that were in charge of doing all that artwork, they are F# programmers. And they do like their F# more than C#. It's very interesting. Anyways, let me talk a little bit about the underlying core runtime. Like I mentioned, iOS was a very statically typed system, and there's many benefits to statically typed. First one is it consumes very little memory. It starts up faster, but it was a little bit more cumbersome for us to develop. So the Mac version used a completely dynamic system. So we're getting rid of that dynamic system, and we're adopting completely on the Mac the same approach that we're using for iOS. So it's an entirely static system. It reduces memory usage. Improves startup speed, but most importantly, it gets us to the same spot that iOS is. So Mac and iOS become the same. Now, probably the most important change that we did last year is that we switched the startup system, the system that integrates the Objective-C world with the C# world. It allows us to do a couple of things. The most important thing is it allows us to support generic subclasses of NSObject. So whenever you subclassed NSObject, so this is the native Objective-C object, whenever you subclassed it, you were not really allowed to use generics. We noticed this because people started using it, and we said, no, you can't do that. So we turned that into a warning. And when people kept doing it, we turned that into an error, and people got upset. And they said, you should fix it. Like, we understand, but right now what you're doing is just unsafe. So eventually we went and fixed it. So now you can use generics with NSObject, but it's only allowed if you use our new register. There's a link there that goes through all the small details about this, and I will cover some of the most important ones. The second thing that we did is that by using this new register, we're actually able to link native libraries and only pull the pieces that are necessary. So instead of bringing the entire library to your application, if you're only using a couple of functions, now we perform full linking, and we only bring the pieces that you need, which means that your binaries are smaller. And finally, we had a difference between the simulator and device, and finally you get the same experience on simulator and device. So this has been the default since 7.2.1, and you can always turn it off if you want to, but we encourage you not to do that. So for generic subclasses, this is roughly what it looks like. And I realize that now it's very small and it's very dark. So I apologize for that. But But the essence is that now you can subclass generics. So let me tell you what are the things that you cannot do. So let's move on to that. It is very important that when you export a method to Objective-C, so when you take a C# method and you surface it to Objective-C, it is very important that the method not be generic, because Objective-C has no idea what to pass to your generic method. So when it comes to exporting a method to the other world, which you do with this little keyword called export, it is very important that you do not have a generic property, because the underlying world has no idea what that T is. So you might have created an instance of generic of this generic of T with an int, and if Objective-C sends you a byte, that's not what you expected, and all of a sudden you have some garbage on the stack, right? So it's very important when you surface this the generic methods to unmanaged code that you don't use that. And here's another example. You shouldn't be the same example here. And here's a workaround of what you can do. If you need to do that, you need to use a proxy method. So if you're ever in a situation where you do need to use a generic method, then you can use a proxy that actually casts to the proper type before calling. All right, so now let's talk about protocol support. So the way that we implemented protocols, the mapping between the .NET world and the Objective-C world in the Xamarin products is that we turned protocols into classes, right? And the problem is we couldn't really use interfaces because interfaces require all members of the interface to be implemented, right? And Objective-C has this notion of protocols which are kind of like interfaces. There's a mandatory part and there's an optional part. So we can do the mandatory just fine, but the optional is problematic. Now you might be thinking, well, why don't you make all the optionals required? And the reason is because sometimes Objective-C declares 100 methods as optional. And then you have to implement 100 methods even if you didn't want to. So that was ugly. The second reason was Objective-C sometimes probes for your optional methods. So the runtime sometimes say, oh, I get an object, and then you send a probe message and say, hey, did you implement this particular method? And if it returns yes, it implements a particular behavior. If it returns no, it implements a different behavior. So forcing people to implement all the methods was problematic because it would produce different behaviors. So what we did at the time is we said, all right, we're going to create an abstract class, and then you override this class. And you only override the methods that you're interested in, right? And this works relatively well. It works relatively well, except that it leads to these ugly idioms where you need to always create a separate class, take a pointer to your parent class, and then implement your methods in terms of the containing class. And it works. It works just fine. And in fact, people in Objective-C that want to have separation of concerns have to do this anyway. So, you know, if you're a purist, kudos to you and to everybody that cleans up their code. It works perfect. But a lot of our users, me included, are very sloppy, and we wanted to use the sloppy approach. So we wanted to support the sloppy approach for people on the run. So our new protocol support is made up of a couple of elements. First, we use interfaces to map. So for a protocol, all the mandatory pieces are turned into an interface. So if you want to support a protocol, you implement the interface, and then you have to implement the required methods. And for optional methods, we don't do anything. Instead, we provide an extension class. So that gives you the consumer experience of being able to invoke those methods. So for example, in this particular case, you see that when I call the animator method, there's an animate transition duration, which are optional methods. You still get IntelliSense because we provided those as an extension class, right? So that's the first step. The second step, which is a little bit of the, well, we'll get to that in a second. But what this allows is this idiom, this idiom that I mentioned was a little bit sloppy. Let me walk you through this. This is a very common idiom in Objective-C, right? You create a table view, and then you assign the delegate and the data source. And what we've historically done when you're doing this clean separation of concern is you say new and the name of the class where you implemented your protocol, your subclass, and then you proceeded. But a common idiom in Objective-C is just say, hey, the delegate, it's this class, right? So with the new protocol support, you're able to do this. Now, savvy members in the audience will notice that I'm using the weak property here as opposed to the regular one. So you see weak delegate instead of delegate. And you see weak data source instead of data source. That's because in this particular case, I depend on the classic API. We didn't want to break compatibility. So with the classic API, this is what you have to do. Because the strongly typed version uses the strong types. So you have to use the weakly typed version to be able to do this. So it works, but it's not ideal. So what happens with the unified API is that we're making those strongly typed. So delegate, instead of being an NSO, so delegate, instead of being an I, in this particular case, an I UI table view data source, right? It's going to be, instead of being a UI table view data source, it's going to be an I UI table view data source. So instead of being a concrete class, it's going to be the interface. And that means that now with the unified API, you can use strong types everywhere. So essentially, our protocol support works well on classic, but you have to resort to weak types. And with the unified API, you're able to go back to fully strongly typing while still adopting this sloppier approach to development. Now, the second challenge with protocols is that you do have to that when you implement a protocol, the required part is easy because it's part of an interface, right? So if it's a member of the required methods, that's easy. The IDE takes care of it. You say, I want to override this method, and it will autocomplete, and it'll auto-generate it. Or you can right-click and say, implement the interface for me. The problem are really the optional methods because they don't exist in an interface. They just don't exist. So we're not able to do this in Visual Studio yet, but at least in Xamarin Studio, whenever you try to override, we actually show you the method. So in this particular case, number of sections, that's an optional method. That's not a mandatory method. So when you select number of sections, just like you would with a mandatory API, we modify the IDE so that it actually inserts the method. Now, you'll notice that the difference here is that we insert that export attribute, which is weak. We know it's weak. It's not perfect, but it's a lot better than not having it. So you can still go down the path of strongly typed APIs, super strongly typed APIs, but now we offer you a relatively safe and pretty good way of using the new ones. So like I said, today you still have to use weak, and we're in the process of changing every single one of our protocols to actually go from the concrete class to the interface. It is source code compatible. That's the good news. You don't need to change your source. No source code changes. So that's the good news, but it is binary compatible. So that's why we're not able to do it on Classic. We can only do it with the new API. Now, so essentially, the good news is protocols work wonderfully, and they work even better if you move to the unified API. That's the bottom line. Now, let me talk about a problem that has been an issue for some of our users, which involves reference counting. There are certain scenarios where you can crash your application if you don't keep references to certain objects. So I'll explain a little bit how this works. So we have two classes of objects in Xamarin iOS and Xamarin Mac. We have objects that are peer objects, and these just represent, it's just a wrapper around a native object, right? But whenever you create a subclass and you override methods and you add attributes and fields and you add state, we call this thing managed objects. And each one has, it's a very light kind of object. You don't need to do very much about it because You can create those on demand and destroy them on demand. But the other guys you need to preserve because there's state that needs to be preserved. So they need to be reference counted. Now, the problem is that this design had a scenario where you could end up in a situation where you have all these nested objects that are all peer objects, and they were all collectible. So there was a scenario where you could essentially crash your application when you got a callback. And this is a good example, and it happens in particular with UI table views, because you create objects, in this particular, the cell, you create this object that is a pure peer object, right? So it has no state. Well, we think that it has no state. And then you add a view, and again, there's no managed state to keep track of, so we ignore it. And then you add an event handler, and the event handler, as far as we're concerned, had no state. So the problem is that this event handler wasn't referenced. So there's a scenario where you could get where the code would call you, and you would get a, hey, this object does not respond to this method crash. So that was a problem. So we've introduced a new reference counting system where anytime that you make a state change like this one, we now keep track of this. There's a couple of nice side effects. Ever since we did this, we had a separate system, a peer system, that kept track of the object graph in memory. And that's how things worked, except in this particular case of the table cell. So with the new reference counting, two things happened. One, NS objects became a lot thinner, and they don't consume as much memory. So that's the first thing. And the second one, it reduces some of the cycles that were very difficult to break. You know, when you had to do disposes, it's like, well, I'm not getting rid of this thing, and you had to manually dispose the manual objects to get rid of them. So all of this is gone. All of the crashes are gone, the memory consumption is gone, and the cycles are gone. So right now, it's an opt-in for Classic because we don't want to break the behavior that you guys depend on. But it is the default on Unified. So when you switch to Unified, it will be a change on the API. Rodrigo has a talk tomorrow that goes through all the details about this, and I encourage you to go there. Like I said, you can still opt into Classic, so you just go to the settings and you say new reference counting, and you're in the new world. And on Unified, it's just checked in by default. Now, we've also made a lot of improvements that we shipped recently, but you need to change your projects to support them. So I'll explain to you what these are. This title is wrong, so ignore the title. But these are the build time improvements that we've added to the platform. The blue bars represent the existing system. And most of you that have existing projects that were not created in the last 6 months, so if you created it before, you're going to be in this bucket. So these are your build times. And this is a sample. Hello World, and the large app is an unknown app from a customer that I can't disclose. But this is the time that it takes to rebuild your application. If you enable the new settings that I'm about to describe, then your build times, for large applications, they will be cut in half, roughly. And if you use incremental builds, they will be cut even further. So there's a couple of things that we're doing. We're doing build caching, we're doing incremental, and we're also doing incremental deployment. So the first section on the left side is, these are just raw build times. And the second piece is, you make a little change to your program, you hit build, and now instead of uploading the entire application, we'll only update the pieces that changed, right? So if you only change one assembly, just that assembly will be pushed. If you change some assets or some PNGs, only those PNGs will be pushed. We won't rebuild your entire app, and we won't redeploy the entire app. Now, it's important to keep one thing in mind. When you do this, you only do this during development. You can't ship this thing to the App Store, right? And there's a couple of elements here that I'll discuss. So again, if you created your project a long time ago, the default was different. So this is a setting that you have to enable. There are two things that you need to do. You need to go and enable incremental builds. Right, so you see it right there on the debugging options. You need to add incremental builds. This is the feature that will essentially just build the things that changed, right, and upload the things that changed. And the other thing that is very important, and this is very different guidance than the one that you've received for everything, is you must disable the linker, right? So let me do a quick overview of what the linker does. What the linker does is, it takes your application. There's a number of settings, but it takes your application, and it looks at what methods you use. So for example, if you say console.writeLine, hello world, it'll say, well, the guy needs the console type. It needs the writeLine method, and there's a string. So it also needs system string. And then it goes to writeLine and figures, what do you need with a string? Well, it needs a couple of other things like encodings and character sets. But essentially, it extracts those pieces. It extracts console, writeLine, and anything it depends on, and puts it in a new binary. And that means that the whole framework, which typically measures about 8 megabytes, gets shrunk down to like a couple, like 100K, right? So we only take the pieces that we need and we put it there. And that's what the linker does. Now, the linker here has 3 settings. Don't link, link everything, which is the ideal scenario, or only link the framework code. So that means only link the monotouch stuff, only link the stuff that we distribute. You really should be using link everything. But a few of you, and I'm not naming names, have been using some bad practices. So you depend on some reflection lookups, and you depend on some things to be there for serialization that are not going to be there. So we give you a little break, and we have an option for people that are doing some of this stuff. In particular, some of you that are using NewtonSoft.json. So we do have that option for you. So that is the setting that you should use, either link framework assemblies or link everything. And that's what you should use for the App Store, because you want a tight, small application shipped to your customers. But when it comes to the to development, you don't actually care. So you do need to change this. And the reason why you need to change this is because by doing this, we compile all of MS Corelib, all of system, system XML, system core, system, everything that you're using. We compile it once, and we ship the entire beast over to the device, right? So we build the entire thing, and we ship it over. And then whenever you make changes to your assemblies, we are able to upload just that delta. We don't need to, because you never get to change the core libraries, right? So whenever you make a little change or to your assemblies, we'll just upload that. But if you were to link, that means that if your code, in addition of calling, say, console writeLine, if you call console readline, well, now the MS Corelib that we have is useless, right? Because now you're also calling readline, so we got to rebuild that thing. So this is very different guidance than the one that you've received in terms of the linker behavior. So for development, don't link. For distribution, link. All right. A couple of things that we've done to Xamarin Studio. This is very interesting stuff. So for those of you using iOS 8, we added asset catalog updates. So you can support iPhone 6 and 6 Plus, as well as a new 3x resolution. I know all of you are very excited to go and redo all your artwork. We've added launch images for iPhone 6 and i6 Plus. And at this point, it's getting ridiculous. At this point, it's really getting ridiculous. I thought that it was bad when I had to support 2 image formats for my TweetStation program, now entirely defunct, because Twitter added some rules that were unacceptable. But with the iPad, now you had to add the landscape, the non-landscape, the upside down, the other one. And then it kept getting worse, because then they added the iPad at Retina, so you had to add all those things, but with the high resolution. And now they're adding the 3x, so it is just getting out of control. So now to have a launch screen, just a launch screen for introducing your app, just that, you have to do 1, 2, 3, 5, 6, 7, 8, 9. Anyways, there's a lot. There's a bunch. There's like 15. It's a lot of images, and it takes a long time. So one thing that Apple just introduced, and you can support right now, is use storyboards for your launch screen. So kill all those images. You can kill all of them and replace them with a storyboard. So now you can use the iOS designer to just do whatever you want, and you just add this launch screen.storyboard file to your project. You need to edit a file. It's on the blog. But essentially, this is what you should be doing. Now you support one storyboard. As you can notice, this is the square version of it, so it's using size classes. So you can use constraint design. So use constraint design, lay out your user interface, and now you can ship a single file that will support all platforms. So you don't need to build, you don't need to support those 15 or 20 or how many, well, whatever. You don't need to support all of those. Yeah, very exciting, yes. Some dude actually ships apps on the App Store. And then Apple, of course, says, hey, you don't have a 3x version. Sorry, you can ship your app. So you go back to your drawing board. So app extension support, this is very interesting. We ship with app extension support, and we have to thank the guys at HitSense that helped us debug the custom keyboard. And they helped us debug the today and the share and the action, all these things. So thank you to those guys that helped us during the beta period to debug all this stuff. But now you can build all of these custom extensions. Now, this is the piece that I said that we were forced to support. So what happens is that applications extensions, Apple requires everybody to ship 32-bit and 64-bit extensions. You can't just ship a 32-bit version or a 64-bit version. And the reason we suspect is applications extensions, when you run a 32-bit app, they do some RPC to 32-bit processes and 64-bit to 64-bit processes. They don't do any data conversion. So because of that, what that means is that you must provide both. And that is the reason why we had to ship unified APIs, even if it was not ready. So what that means is that if you're planning on building an app extension, you do need to embrace the unified API. Now, the good news is that if your extension doesn't share any code with your main app, you can still keep your main app on the old, on the classic API, and just build the new stuff using the unified API. So that's the reason why we had to ship it. We were not ready to ship it. We had to ship it to support app extensions. Now, speaking of this, we strongly encourage everybody to use size classes. In the past, developers were designing user interfaces in terms of heights and widths and a couple of iPad form factors. Apple has encouraged developers to strongly to move away from orientation and width and height. And they're encouraging developers to adopt size classes. And size classes are things like it is thin, it is kind of okay, and it is large. And there's a resolution associated with this. But you must adopt this thing, both because new devices like the iPhone 6 and the 6 Plus came out, and there's a fascinating rumor out there about somebody that managed to get the iPad to do side-by-side applications, and they're doing multitasking. So somebody figured this out, and it's all over the press. So we believe strongly that size classes were added for this reason. So you should go and rebuild your applications if you want to support this, or if you just want to support any new devices that Apple comes up with. So we should do that. Alex Corrado has a session on Thursday for the basics of the designer, and there's a separate session that just focuses on size classes. And with that, I would like to get some questions from you. Thank you. And again, remember, there's iOS 8 specific sessions and designer specific sessions. This was just about the runtime. Yes, sir? Yes. We don't have support for wrapping Swift libraries, but we're working on that. I don't know what shape it's going to take, but the good news about Swift is that Swift actually has a very strongly typed system, something that didn't exist in Objective-C. So a lot of the work that we did with Xamarin iOS is actually, every time that they say, oh, this returns an array, it's like, well, an array of what, right? So we have to go and write test cases and read documentation to give you a strongly typed view of that. With Swift, the information is there. So not for Apple frameworks, because Apple hasn't switched to Swift yet, but when you bind a third-party component, somebody that builds a Swift library, we will have that information. So we don't have that support yet, but we're working on it. And that's the good news, that a lot of the stuff that was very manual in the past can be automated with Swift. And the second thing is they support generics, which we love. So it's going to be a nice integration between C# and Swift. The question is, how are you going to support what Swift calls enums, which are what C# calls, F# calls type records? I think that what we're going to do is we're going to map it to a class. Essentially, it's a class, right? They call it enums, but it's just a class with a bunch of constants inside. And in fact, C# enums are really instances of subclasses of the enum class. It happens to have a few constants. So I think we're going to map it to classes. I'll know more in the future. There's a proposal right now for C#7 for pattern matching, and it requires type records. So whether we go down the path of C# with type records, or whether we go down the path of just a C# class for those enumeration values, I don't know the answer to that yet. But we're working on that. It's already there. It's there. It is so there. You need to change it. There's a setting on Xamarin Studio where you can enable C#6. C#6 is not officially released, so the language can change. And this is a funny case because we're in the weird position where we support everything that was official in C#6 as of 2 weeks ago, as of a week ago, and some more. And then they just pulled out 2 features. So we're in the position where we have features that are actually not shipping anymore. So get it while it's hot, because we're turning it off. It will still be available. So Mono has multiple levels. You can specify the language version, so 2, 3, 4, 5, 6. And then we have experimental. So we're in the process of moving these 2 features from 6 to experimental. But this thing just hit us on Thursday, I think, or Wednesday. So you can still get it today if you set it to C#6. On experimental, we're going to move this feature, and we also have pattern matching implemented. So there's a proposal going on for pattern matching, like F# style or Swift style pattern matching. We have it implemented. It's on the experimental bit. We're still using our compiler on macOS because our compiler is a lot faster than Roslyn. But as soon as Roslyn has debug support, we'll enable both. So you'll choose either Roslyn compiler or the Mono compiler. And the goal is that eventually, we'll just transition to Roslyn. We don't know when that's going to happen, but we'll give you the option soon enough. Yes, you can definitely use still, for your own use, you can use reflection emit. We're just not going to impose the overhead of reflection emit on our customers for startup. So yes, you can still use it. For the registrar, yes. If you want to use a unified API, yes. Now, that doesn't mean that you don't get access to reflection emit. You can still use it for your code. It's just that we are not going to use it anymore to startup. So it's gonna be just faster startup. But if you have some library that generates code dynamically for performance reasons, you can still do it, like Android. We still support reflection emit there. We're just not going to put it in your startup sequence. Does that make sense? There was another question around here. Yes? Yeah. So these data types only exist. Yeah. Oh, I'm sorry about that. The question is, how do you share code that is using the new data types nint and nfloat when you're sharing code with Windows? And the answer is you shouldn't use that in cross-platform code. These are data types that are specific to iOS and Mac. They don't really exist on Windows. So for your shared code base, you shouldn't use them. And typically, the only reason why you need to use these things is in scenarios where you're invoking a method that happens to return an nint, like for example, get row height. Now it's going to return an nfloat. So the only place where you're forced to use the new data types is when you're building UI code or code that actually interrupts with the native API. So this is code that, just as a rule, shouldn't happen on your code base. So as a rule, it shouldn't be there. So I don't think that you're going to, in real life, I don't think that you're going to end up seeing this. But we thought about this, and we thought maybe we should move into separate assembly, but we didn't see a good reason why this would be a scenario that would actually happen in practice. It is very platform specific. So it would only happen in that platform specific piece. And if we're wrong, we're happy to course correct. If we're wrong, we'll fix that. But for now, it doesn't seem like we have a scenario. Yes?
Just to follow on to that, what about Android and 64-bit support on Android? Do these data types work across data?
The question is whether these data types will work with Android. We don't believe that, first off, we could make them work on Android if we needed to. Right now, there's no official 64-bit Android support. Now, Android is kind of on the same boat as C# was. They've chosen their data type, and they're going to have to use that data type. Changing to 64 for them would also be a breaking change. So we believe, an educated guess, is that 64-bit supporting Android would come in the form of extensions to the existing methods, right, or extensions to existing classes. So if you see 64-bit support, you'll see it as new methods or new data types in the API, as opposed to replacing the existing ones. So we don't think that we're going to need them. If it happens that we need them, we would bring these data types there. But right now, there's no indication that that would be the case. Yes? That's a good question. No. We don't have plans. It's an interesting idea. I'm sorry. The question is, are we going to add support to the Mac to Test Cloud? And the answer is, we don't currently have plans, but it's an interesting idea, and I haven't thought this through. Let me think about it. I'll make a note. Yes, that is a question. It's, yeah, I hadn't thought about that. Maybe. Yes?
Incremental builds are just great, but why is the Xamarin Studio considered build native code every time I hit run?
So the question is, incremental builds are great, and you're great, and I am great? No, I'm kidding. Incremental builds are great, but there seems to be some rebuilding action taking place every time you hit run.
Even if I didn't change it.
I don't know the answer to that. That sounds like a bug. The good news is that the team that maintains that code is here. If you guys can wave on the back. So we'll be very happy. And Rolf is over there. So we'll be very happy to look at your project and see what's wrong. It's probably a bug in our code. We'll be happy to fix it. There was another question here. Yes?
Yeah, I was wondering if there would be like Xamarin forms for our Xamarin.max something like that. Maybe the XAML editor for Xamarin.mac would be nice.
So the question is whether we're going to have Xamarin Forms for the Mac. I don't know how to answer that. How does one answer this? Well, I can tell you one thing. I'll say this. We are expanding the reach of Xamarin Forms, but at this time, we don't have an announcement to make. Otherwise, Nat just gets upset with me when I pre-announce things. And, why did you do that? So don't take that as an announcement. I didn't say that. Do not tell Nat I said anything. Yes, guy on the back. Would you consider adding Swift as a language to program Android and Windows Phone? We've thought about it. Our focus right now is really C# and F#. I mean, I like Swift. I think it has some really great ideas. I do like them. But we feel that Swift is a little bit like what F# pre 1.0 was. So it definitely has great ideas. It has great potential. But right now, we have F# 3.0. So it's a couple of generations ahead in terms of functional programming and what it can do than Swift does. Now, I understand that there's some excitement around Swift, and you want to write some Swift code. There are a number of options out there. A couple of people have managed to get the Apple Swift compiler to generate Android code. There's 3 or 4 open source efforts doing that. There's a F# compiler implementation for Swift written by Frank Kruger, who seems to produce more code than most companies can in a day. But right now, we're not planning on creating a product around this. Our focus right now is we have a lot in our plate, and we're going to focus on those. If somebody does something, we'll be happy to support them for now. But we don't have any plans right now. We really like F#, we really like C#, and as you saw, we have 3 big previews ahead of us, and we kind of want to nail those three, make sure that they're excellent and perfect before we take on more stuff. Swift, it's an interesting idea from every programmer wants to build one of these, but it would be distracting for us. So right now, we want to focus on those two things. And F#3 is really, Don Syme has really done an excellent job. It's a very sophisticated, very advanced functional programming language, beyond anything you've seen before. If anything, type providers are just mind-blowing, amazing. You should go to Rachel Reese's talk, because once you see type providers, you cannot believe how amazing that stuff is. But if you want to build a Swift runtime, we can probably provide some help and IDE support and that sort of thing. But right now, we don't have plans. Yes? Can you speak up a little bit? It's a little bit difficult to hear you.
Protocols were mapped to events and delegates in C#, and we couldn't use events and a class, an after class that maps the protocol.
Yeah, I understand.
Can we now use events and interface?
I hear. Yeah. So the question is, there's a scenario where you cannot use both overriding the manual delegate property and the C# events, and that limitation is still there. So the same rules that apply to the previous code exist today. That said, we have a prototype from James Clancy that actually allows both to work together, and we're reviewing that. And if we can make it work reliably and address all the corner cases, we will add it. But right now, the rules are still the same. All right. Well, thank you very much, everybody.